Hello. In this problem, we are going to solve the required brake force P that will stop the rotating drum from rotating and thereby stopping the block in 10 feet. So in this figure, we can see that there is a rotating drum pulled by this weight B, and this rotating drum is to be stopped using this brake lever. Okay, by applying a force here, the friction here will this brake pad will press against the drum and stop the falling weight here. So in the rotating drum in the figure, it has a centroidal mass moment of inertia of 10 foot-pound second squared. The coefficient of friction here at the brake is 0.25. At the instant the brake is applied, block B has a downward velocity of 20 feet per second. What is the constant force P applied at the brake lever needed to stop block B in a distance of 10 feet? Okay, so what is given here is a brake lever on a rotating drum. Initial velocity of block B is 20 feet per second going down, and it should stop in 10 feet. So we need to find the force here, the brake force P, in order for block B to stop, to be stopped in 10 feet. So before we can solve that, we should be able to know the deceleration of block B. So this is the formula that we are going to use. V squared is equal to V sub O squared plus 2AS. So adapting this formula to block B, we have V sub B squared is equal to V sub O sub B squared plus 2 times A sub B times S sub B. So since block B will have zero final velocity, it will be equal now to the initial velocity, which is 20 squared, 20 squared plus 2, acceleration of block B is unknown, times S, which is 10. So the acceleration of block B, computing for this one, is negative 20 feet per second squared. Now, converting this acceleration into angular acceleration, we use the formula A is equal to R alpha. So acceleration of block B is equal to R, which is 2 feet, times alpha B. So this one is negative 20 is equal to 2 times alpha of B. So alpha of the rotating drum, will be equal to negative 10 radian per second squared. Okay, so we are going to have the FBD of the block B as it moves down, so we are going to apply this formula for rectilinear translation. Summation x is equal to W over G times A. So the forces involved in the direction of x, which is vertical in this case, is weight of B minus T. Okay, so that is weight of B minus T is equal to the weight of B over G times acceleration of B. Substituting values, we have weight of B is 100 minus T is equal to the weight of B 100 over G 32.2 times acceleration of block B is negative 20. Solving for the tension in the cable, it is T equal to 162.1 pounds. Then after that, we are going to look at the FBD of the drum. The forces involved are the tension on the cord and the friction with a normal force, the force that is pressing against the drum. So to solve for these forces here, we need to understand that the friction is equal to F times N. So to solve for that, we are going to take a summation moment is equal to I alpha. So the moments here caused by T is T times the radius 2 feet, and caused by F, it is F times 3 feet. So T times 2 minus F times 3 equal to 10 times I is 10, alpha is negative 10. So substituting values, F here, the frictional force is 141.4 pounds. So solving for N, we have this formula. So N is 565.6 pounds. So for the brake lever, the FBD looks like this. So the forces involved are this N, F, and this P. So this one is now in the statics, no? So we are going to apply the formula for statics. So F is counterclockwise, N is counterclockwise about O, and P is clockwise. So summation moments about O is equal to 0. So this P times the total distance is 4 minus N times 1 minus F, and the distance here is 1/2 of a foot, so 0.5 feet. So equal to 0. So solving for the P, substituting values, we have P is equal to 159.1 pounds. So this 159.1 pounds is the force needed to be applied, no, at the tip of the brake lever in order for this drum to stop rotating, and this weight will fall for only 10 feet. Thank you.